Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Today's video, we are back inside of TryHackMe, continuing on with the Cybersecurity 101 learning path. This is the web hacking module. This is the JavaScript Essentials Room. Learn how to use JavaScript to add interactivity to a website and understand associated vulnerabilities. Hopefully, you're all having an awesome day today and ready to learn something. Let's go ahead and dive into it. Task 1, Introduction. The JavaScript, also known as JS for short, is a popular scripting language that allows web developers to add interactive features to websites containing HTML and CSS styling. Once the HTML elements are created, you can add interactiveness like validation, on-click actions, animations, etc. through JS. Learning the language is equally important as that of HTML and CSS. The JS scripts are used primarily with HTML. This room is designed as an introductory overview of JS, specifically tailored for beginners with limited JS experience. The primary focus is on teaching the fundamentals of JS from a cyber perspective and how hackers utilize legitimate functionalities to achieve malicious results. Room prerequisites, Linux fundamentals module, web application basics, and how websites work. Learning objectives. Understand the basics of JS, integrating JS and HTML, abusing dialog function, bypassing control flow statements, exploring mini-field files. Exploring minified files. Connect to the machine. I've already have it started up over here. As you can see here, it says note. All the scripts we created in this room are also available in the exercise folder on the desktop of the attached VM as shown below. If you find it difficult to create these scripts yourself, you can also use the provided ones. Awesome. So let's go ahead and continue on here. Not sure why this is lagging so much, but okay, let me scroll down if I can. All right, task number 2, essential concepts. Variables. Variables are containers that allow you to store data values in them. Like any other language, variables in JS are similar to containers to store data. When you store something in a bucket, you also need to label it so that it can be referenced later on easily. Similarly, in JS, each variable has a name. When we store a certain value in a variable, we assign a name to it to reference it later. There are 3 ways to declare variables in JS: var, let, and const. While var is function scoped, both let and const are block scoped, offering better control over variable visibility within specific code blocks. Data types. In JS, data types define the type of value a variable can hold. Examples include string, which is text, number, boolean, true, false, null, undefined, and object. For more complex data like arrays or objects, functions. A function represents a block of code designed to perform a specific task. Inside a function, you group code that needs to perform a similar task. For example, you are developing a web application in which you need to print students' results on the web page. The ideal case would be to create a function print results roll num that would accept the roll num of the user as an argument. And here's an example of that script here: print result roll num, and inside there is alert username with roll number plus roll name, etc., etc. Any logic to display the results for let I equals 0, semicolon I is less than 100, semicolon I plus plus, print results roll numbers I script. So instead of writing the same print code for all the students, we will use a simple function to print the results: loops. Loops allow you to run a code block multiple times as long as a condition is true. Common loops in JS are for, while, and do, while, which are used to repeat tasks like going through a list of items. For example, if we want to print the results of 100 students, we can call the print results roll num function 100 times by writing it 100 times, or we can create a loop that will be iterated through 1 to 100, and we'll call the print results roll num function as shown below, and that's what they're talking about here. And you can see here in the comments, this will be called 100 times. Request response cycle. In web development, the Request response cycle is when a user's browser, the client, sends a request to a web server and the client or the server responds with the request information. This could be a web page, data, or other resources. You can learn more about it here, so check that out if you're interested. What term allows you to run a code block multiple times as long as it is a condition? And that's going to be loop, as they discussed loops up here. Loops allow you to run a code block multiple times as long as the condition is true. All right, task number 3, JavaScript overview. In this task, we'll use JS to create our first program. JS is an interpreted language, meaning the code is executed directly in the browser without prior compilation. Below is a sample JS code demonstrating key concepts such as defining a variable, understanding data types, using control flow statements, and writing simple functions. These essential building blocks help create more dynamic and interactive web apps. Don't worry if it looks a bit new now. We will discuss each of these concepts in detail later on. Hello world program. Okay, console.log, hello world. Variable and data type, let age equals 25, control flow statement, function, and calling the function here. JS is primarily executed on the client side, which makes it easy to inspect and interact with HTML directly within the browser. We'll use the Google Chrome console feature to run our first JS program, allowing us to write and execute JS code easily without additional tools. Follow these steps to get started. Open Google Chrome. So let's go ahead and open this up by clicking the Google Chrome icon on the desktop of the VM. Okay, we already did that. Once Chrome is open, Control-Shift-I will open the console, or right-click anywhere on the page and select Inspect. All right, so let's just right-click and then Inspect. Okay. Then click the Console tab, which is this here. The console allows you to run JS code directly in the browser without installing additional software. Okay. Let's create a simple JS program that adds two numbers and displays the results. Below is the code. All right, so let's go and type all this out. It's best to probably type these out instead of just copy and pasting it in this case, so that you can build up that muscle memory and oops, yeah, build that muscle memory. See if I did this right. I've never done this inside of this area here before. Maybe okay. I guess it's shift and then enter. So let's go ahead and continue on. Let y equals 10. Hopefully this doesn't mess up somewhere. X plus y. Okay. Then console.log. Okay, the result is space, double quotes, then plus result. Okay. All right, looks good. In the code above, x and y are variables holding the numbers. X plus y is an expression that adds the two numbers together, whereas console.log is a function used to print the result to the console. Copy the above code and paste it into the console by pressing the key Control plus V. Once pasted into, press enter, you should see the result displayed. Okay, I guess you could copy and paste, but whatever. Let's go ahead and hit enter. Okay, the result is 15. Awesome. Congratulations, you've successfully created your first program in JS. This is just the beginning, and there's much more to explore as we dive deeper into JS in this room. What is the code output if the value of x is changed to 10? Okay, the result's going to be 20. So if you want to do that again, you're going to go ahead and just copy and paste like so. Okay, and then we're going to change x to 10. Right, so 10 plus 10 is going to be 20. There you go. Is JavaScript a compiled or interpreted language? Well, that's going to be an interpreted language, as it's stated up above here, where it was talking about this area here. So there you go. And now let's continue on to the next one. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. Task 4. Integrating JavaScript in HTML. This task assumes you have a basic understanding of HTML and its structure. This section will explore how JS can be integrated into HTML. Usually JS is not used to render content. It works with HTML and CSS to create dynamic and interactive web pages. If you're unfamiliar with HTML, reviewing it through the provided link is recommended, so check that out. There are two main ways to integrate JS into HTML, internally and externally. Internal JavaScript. Internal JS refers to embedding the JS code directly within an HTML document. This method is preferable for beginners because it allows them to see how the script interacts with the HTML. The script is inserted between the script tags here. These tags can be placed inside the head tag or head section. They're typically used for scripts that need to be loaded before the page content is rendered, or inside the body section where the script can be utilized to interact with elements as they are loaded on the web page. Example, to create an HTML document with internal JS, right click on the desktop and select create document, then select empty file, name the file internal.html. Okay, there we go. I'm just going to move it up here a little bit. Okay, and it says, and choose open with Pluma. All right, so we've done everything here. Once the editor is open, paste the following code. So let's go ahead and copy this over. Awesome. After pasting the code, click File and Save, and which will save the file to internal.html. Double click to to open it in Chrome browser. Well, where you will see the following output. So let's go ahead and close out of this, and there we go. And yeah, addition of two numbers, the result is 15. In the HTML document, we are using internal JS, meaning the code is placed directly inside the HTML file with the script tag. The script performs a simple task. It adds two numbers, x and y, and then displays the results on the web page. The JS interacts with the HTML by selecting an element, which is the P, with ID equals, and then inside double quotes result, and updating its content using the document.getElement by ID results dot enter HTML. This internal JS is executed when the browser loads the HTML file. External JavaScript. External JS involves creating and storing JS code in a separate file, ending with a .js file extension. This method helps developers keep the HTML document clean and organized. The external JS file can be stored or hosted on the same web server as the HTML document, or stored on an external web server such as the cloud. We will use the same example for external JS, but separate the JS code into a different file. First, create a file named script.js and save it on the desktop with the following code. So let's go ahead and minimize this. And we're going to follow the same process here. So script, if I can spell script.js. Okay, move this up here a little bit, open with Pluma, and then we're going to copy this over. All right, it says next, create a new file named external.html. So let's go ahead and save this. And then we will close out of this, create a new file again. Okay, so there we go. Now open with Pluma. Okay, and paste the following code. Notice that the HTML code is the same as that of the previous example. Okay. All right, saved. Now double click the external.html file and check the results. Do you see any difference? No, the output remains the same as the previous example, right? What we did differently is use the source attribute in the script tag to load the JS from an external file. When the browser loads the page, it looks for the script.js file and loads its content into the HTML file. This approach allows us to keep the JS code separate from the HTML, making the code more organized and easier to maintain, especially when working on large projects, okay? And if you take a look at this again inside of Pluma, you can see what they're talking about here. And if you go look at this again, it says the same code, but open with Pluma, right? Source equals script.js. Okay. Verifying internal or external JS. When pen testing a web application, it is important to check whether the website uses internal or external JS. This can be easily verified by viewing the page source code. To do this, open the page external underscore test. And, okay, I think it just, where is this file then? Oh, it's an exercise. Okay. This can be verified. To do this, open the external underscore test.html, locate an exercise folder in Chrome, right click away, right click anywhere on the page and select view page source. So let's go ahead and do that here. Okay. View page source, which is this here. Okay. Can you verify the JS? And it says link to external JS file right here. And it's commented out, it looks like. This will display the HTML code on the rendered page. Inside the source code, any JS written directly on the page will appear between script tags without the source attribute. If you see a script tag with a source attribute, it indicates that the page is loading external JS from a separate file, right? And that's what I just showed here. For a practical example, visit tryhackme.com in your browser and expect the source code to identify how the website loads to JS internally and from the external sources. All right, I'm just going to look at this picture here. And that's exactly what it looks like. Okay. Questions. Which type of JavaScript integration places the code directly within the HTML document? That's going to be internal, as we just talked about up above. Which method is better for reusing JS across multiple pages? That's going to be external. It said it was easier to maintain, right, as we read through that, due to differences and such up here. And the next question says, what is the name of the external JS file that is being called by external underscore test.html? Well, you can see that here. It's going to be thm underscore external.js. What attribute links an external JS file in the script tag? Well, that's going to be the source. As you can see here, inside the script tags, you got source right here, source equals. All right. So that's that one. Task number 5, abusing dialog functions. One of the main objectives of JS is to provide dialog boxes for interaction with users and dynamically update content on web pages. JS provides built-in functions like alert, prompt, and confirm to facilitate this interaction. These functions allow developers to display messages, gather input, and obtain user confirmation. However, if not implemented securely, attackers may exploit these features to exclude attacks like cross-site scripting, also known as XSS for short, which you will cover later in this module. We will be using the Google Chrome console in the upcoming exercises. Alert. The alert function displays a message in a dialog box with an OK button, typically used to convey information or warnings to users. For example, if we want to display hello THM to the user, we would use the alert. Then inside of these um, open and close parentheses inside of these double quotes, you got hello THM, and you have the semicolon. To try it out, open the Chrome console, type in alert, and then the following here, and press enter. A dialog box with the message will appear on the screen. All right, so if we go back to this here, I guess, and let's see, we're just going to copy and paste this information over like so. There we go. Prompt. The prompt function displays a dialog box that asks the user for input. It returns the entered value when the user clicks OK, or null if the user clicks cancel. For example, to ask the user for their name, we would use prompt, what is your name, inside of these parentheses, double quotes, and then semicolon. To test this, open the Chrome console and paste the following that asks for a username and then greets them. So let's go ahead and do that here. And let's see. I'm not sure how to clear this out, but maybe if I close it and then try it again. Oops, I don't want to do that. I want to go to inspect. Awesome. Okay. So let's paste this in here. Hit enter. There we go. Type in my name. WireDogSec. Okay. Hello, WireDogSec. Once you paste the code, hit enter. A dialog box will appear, and the value entered by the user will be returned to the console. Okay. Awesome. And we're going to talk about confirm here. The confirm function displays a dialog box with a message and two buttons, OK and cancel. It returns true if the user clicks OK and false if the user clicks cancel. For example, to ask the user for confirmation, we would use confirm inside of parentheses and double quotes, are you sure, question mark, then a semicolon at the end. To try this out, open Chrome, console, and then we're going to do the same thing here pretty much. Confirm, do you want to proceed? And enter, okay. So let's go ahead and do that. And we should get something like this. Okay, semicolon. Do you want to proceed? Yep. Okay. All right. Okay, are we supposed to put both of them in here? Let's see here. Okay, then we need to put, are you sure? Yeah, okay, there we go. A dialog box will appear, and depending on whether the user clicks OK or cancel, the value true or false will be returned to the console. How hackers exploit the functionality. Imagine receiving an email from a stranger with an attached HTML file. The file looks harmless, but when you open it, it contains JS that disrupts your browsing experience. For example, the following code will show an alert box with the message field hacked 3 times. All right, so we got title hacked, and then let's for let I equals 0, I less than 3, plus plus. Okay, hacked. All right. On the desktop on the attached VM, create a file called invoice.html and paste the above code. Double click the file to open it, and the alert message will pop up 3 times, causing an undesired experience. Okay, so let's go ahead and copy all this over, and we will minimize this here, minimize that, and then we need to create a new file. Okay, invoice. Okay, I'm gonna move it up here. So we're gonna open it up in Pluma again. We're gonna paste this over. Okay, that's weird. Didn't copy it. Let's go ahead and do it again. Oh, it did. It was just lagging. All right, let's delete all this. Okay, that was weird. Let's try this again. Oh, okay, I don't know what's going on. This machine's lagging or something, but it's in there. So we're gonna hit Control S, save this. All right. And it said it wants us to open this up. Say, okay, there's 1, 2, 3. Imagine if a bad actor sent you a similar file, but instead of displaying the alert 3 times, the number is set to 500. You would be forced to keep closing the alert boxes one after another. This is a simple example of how malicious JS can be used to create an inconvenience or worse. Therefore, ensuring you only execute JS files from trusted sources is crucial to avoid such an undesired experience. That's probably how these tech support scam pop-up messages lock up your machine. It won't let you exit out of that screen. They probably use something like that in the background. Anyway, let's continue on. In the file invoice.html, how many times does the code show the alert hacked? So if we go back and take a look at invoice.html, So we're gonna open up with Pluma. Let's see. I wonder if they want us to, if they're talking about the one inside this here. Okay, yeah, probably this one. Open with Pluma. Yeah, there's 5. Which of the following JS interactive elements should be used to display a dialog box that asks the user for input? Well, that's going to be prompt, as we just talked about up here. Okay, talking about prompt. And if the user enters Tesla, what value is stored in the car name equal prompt? What is your car name and the car name variable? Well, that's going to be Tesla, okay? Because that's what they just entered in it. And if you go back and read through prompt, it'll tell you that information. And you can also try it out, I guess, if you want to play around with the console thing on here. Task number 6, bypassing control flow statements. Control flow in JS refers to the order in which statements and code blocks are executed based on certain conditions. JS provides several control flow structures such as if, else, switch statements to make decisions in loop like for, while, and do while to repeat actions. Proper use of control flow ensures that a program can handle various conditions effectively. Conditional statements in action. One of the most used conditional statements is the if-else statement, which allows you to execute different blocks of code depending on whether a condition evaluates to true or false. To test this practicality, let's create a file, h.html. So let's go ahead and close out of all this stuff and create documents, empty file, okay, and age.html. Awesome. And we're going to open this up in Pluma. So they're going to want us to copy and paste this over. Hopefully it doesn't lag this time. There we go. Control S to save it. Double click the file to open it in Chrome. You will see the following image. All right, let me exit out all these tabs. Okay. What is your age? Awesome. So 21. Sure. You're an adult. In the above code, a prompt will ask for your age. If your age is greater than or equal to 18, it will display a message saying you are an adult. Otherwise, it will show a different message. This behavior is controlled by the if-else statement, which checks the value of the age variable and displays the appropriate age or message based on the condition. So if that, we'll say, I don't know, 16. Okay, you are a minor. Bypassing login forms. Suppose a developer has implemented authentication functionality in JS where only users with the username admin and passwords matching a specific value are allowed to log in. To see this in action, open the login.html file in the exercises folder. So let's go ahead and do that. And there it is. So let's go ahead and take a look here. Okay. When you double click the file and open in your browser, it will prompt you for a username and password. If the correct credentials are entered, it will display a message confirming that you are logged in as shown below. So yeah, username equal prompt. You can see the rest here, the actual code itself. And let's go ahead and open this up in Chrome. All right, what's your username, password? All right. When you double click the file and open in your browser, prompt your username and password. If the correct credentials are entered, it will display a message confirming you're logged in, shown below, as we just read that. I guess that's it for this one. And just want to take one more look at this real quick. Yeah, okay. All right, question time. What is the message displayed if you enter the age less than 18? Well, we already saw that, which was you are a minor. What is the password of the user admin? And let's go ahead and take a look here. Let's see. So Open this up again, and it says password equal to complex password. Okay, so if we go in and type this in, it's username admin, and you can see complex password. There you go. Task number 7, exploring minified files. We have understood how JS works and how we can read it until now, but what if the file is not human readable and has been minified? Minification in JS is the process of compressing JS files by removing all unnecessary characters, such as spaces, line breaks, comments, and even shortening variable names. This helps reduce the file size and improves the loading time of web pages, especially in production environments. Minified files make the code more compact and harder to read for humans, but they can still function exactly the same. Similarly, obfuscation is often used to make JS harder to understand by adding undesired code, renaming variables and functions to meaningless names, and even inserting dummy code, which is very annoying if you ever do malware analysis and stuff like that. Practical example. Create a file on the desktop of the attached VM named hello.html. So let's go ahead and do that here. Close out of all this stuff. Okay, and hello.html. Paste in the following code. Okay, now Control V and then Control S, save it. Now we're done with that. Then create another file, name hello.js. Oh, I meant not to do that. I meant to do a empty file. There we go. And you're going to put this information inside there. Okay. Now double click the HTML file here. Open in Chrome. Once the file is open, you see an alert greeting you with welcome to THM. Okay. Click the OK to close the alert dialog box. Right click anywhere on the page and inspect. Look at the developer tools. So we're going to go over to sources tab and click on the JS file to view the code. You will see that the JS code is easily accessible and viewable as below. Yes, okay. Obfuscation in action. Now we will try to minify and obfuscate the JS code using an online tool. Visit the website here and copy the contents of hello.js and paste them into the dialog box on the website. The tool will minify and obfuscate the code, turning it into a string of gibberish characters as shown below. And it's the JavaScript obfuscator, so I'm just going to copy this link and paste it over here. All right, I'm going to go back up here and get this ready to go. And this is loading very slowly. But what if we tell but what if we tell you that these gibberish characters are still fully functional code? The only difference is that they are not human readable, but the browser can still execute them correctly. The website converter, converted our JS code into this one here. Looks like that. Yeah, a bunch of gibberish stuff. Copy the clipboard highlighted as 2 in the above image. Button as shown on the website, then remove the current content of hello.js on the attached VM, paste the obfuscated content in the file, reload the HTML file in Chrome, inspect the source code again. You will notice that the code is obfuscated but still functions exactly as before. Okay, well, let's go ahead and skip forward because this is going very slow for some reason. All right, so here is the result. I have the original code here and I have the gibberish code over here. So let's go ahead and copy this over and navigate back here and let's go ahead and close out of this. And we need to open up that file again. And we are going to delete all this stuff and paste this gibberish in there. Okay, finally it was able to paste and I've already saved the file. So I'm gonna close out and go back into this here. Okay. And let's go ahead and inspect sources, JS. All right, there it is. Okay. And let's take a look here, deobfuscating a code. We can also deobfuscate an obfuscated code using an online tool. Visit the website here, then paste the obfuscated code into the provided dialog box. The website will generate the equivalent human-readable JS code for you, making it easier to understand. So this is what it looks like there. So let's go ahead and take a look at this website. Hopefully this doesn't lag. Let's try this again. Okay. And let's copy. Okay, copy the clipboard. We're going to go back over here, delete all this stuff out. All right, there we go. That was weird. I wonder why it didn't work the first time. But anyway, you see that it works. And question time. What is the alert message shown after running the hello.html? Well, we saw that said, welcome to THM. What is the value of the age variable in the following obfuscated code snippet? And so they want us to use that site again to deobfuscate it. So let's flip back over there, delete all this stuff out, paste, and deobfuscate. 21 is going to be our answer. And there we go. Task number 8, best practices. This task outlines the best practices for evaluating a website or writing code for a website. If you are developing a web application, you will likely end up using JS on your website. The practices below will assist you in reducing the attack surface and minimizing the chances of attack. Avoid relying on client-side validation only. One of JS's primary functions is performing client-side validation. Developers sometimes use it for validating forms and rely entirely on it, which is not a good practice since a user can disable/manipulate JS on the client side. Performing validation on the server side is also essential. Refrain from adding untrusted libraries. As discussed in earlier tasks, JS allows you to include any other JS scripts using the source attribute inside a script tag, but have you considered whether the library we include is from a trusted source? Bad actors have uploaded a bundle of libraries on the internet with names that resemble legitimate ones, so if you blindly include a malicious library, you will expose your web application to threats. Avoid hard-coded secrets. Never hard-code sensitive data like API keys, access tokens, or credentials into your JS code, but some developers still do that, as the user can easily check the source code and get the password. That's why you should check the source code, and you can find some juicy stuff in there. Bad practice. Constant private API key equals this here. Minify and obfuscate your JavaScript code. Minifying and obfuscating JS code reduces its size, improves load times, and makes it harder for attackers to understand the logic of the code. Therefore, always minify and obfuscate the code when using code in production. The attacker can eventually reverse engineer it, but getting the original code will take at least some effort. Is it good practice to blindly include JS in your code from any source? Well, no, it's not. And that's with pretty much any programming language out there. You just don't want to randomly use random libraries and stuff out there because you don't know what's in there. You could be accidentally backdooring your own environment. Task number 9, conclusion. So let's go ahead and wrap this up. Congratulations on completing the JavaScript Essentials room. We've covered important topics like the basics of JS, creating our first JS code, and integrating JS in HTML. Moving forward, we discussed other interactive elements of JS like prompts and how attackers can abuse them. Then the room highlighted the usage of control flow statements and how they can be bypassed in JS. We then explored how to use minify and obfuscate a JS file and learned the other way around. Lastly, we touched upon some best practices that you can follow to keep your web app safe from cyber threats. Keep learning and stay vigilant against security threats. Your journey as a JS developer has just begun. Let us know your thoughts on this room in our Discord channel or X account. See you around. I have successfully completed this room. Awesome. Hopefully you're all join me, tagged along, learned something valuable from this room. If you did, hit that like button. If you're new here, hit the subscribe button with the notification bell so you know every time I post or upload a video. Share, comment below your thoughts and opinions on the information shared. As always, thank you all for taking the time to watch my video. Have a nice day, and I will see you later.